This is a real gas example problem. So this says estimate the volume of carbon dioxide at 500 degrees Kelvin and 100 atmospheres by treating it as a van der Waals gas. We're given the A and B van der Waals coefficients and the van der Waals equation. So let's write down what we know. It's at 500 Kelvin and 100 atmospheres. This is my pressure. This is my temperature. The A van der Waals constant is 3.610 atmospheres times liters squared divided by mole squared. And the B constant is equal to 0.429 liters per mole. And then I need my van der Waals equation, and it's a little complicated, but I just looked this up. It's the pressure plus the A constant times N squared divided by V squared, and that quantity is multiplied by the volume minus the number of moles times the B constant, and that's equal to the number of moles times the gas constant times the temperature. So I'm going to have to rearrange this equation a little bit in order to figure out what the molar volume is. And that's how many moles there are in a given volume, or N divided by V. And so, if I divide both sides by N, let's see what happens. Now this side is easy, I get RT, but this side, I have to decide what to do. I don't divide N into both sides, just one, and I notice that I have N divided by V here. So let me work on this side. I'm going to get my volume divided by N minus B, and here I'm going to write this a little bit differently. This is P plus A divided by V over N squared. And that's equal to RT. And so this is wrong. I have this upside down. This is the volume divided by the moles. In other words, how much volume does 1 mole take up? And now I can subtract RT from both sides. And what I'm going to get is P plus A divided by V divided by N squared times V divided by N minus B minus RT is equal to 0. And I want it to be equal to 0 because it's easier to solve in Excel that way. And so I can either leave it this way or I can cross multiply these terms. I think I'll just leave it this way because I can calculate that in Excel, and I am looking for a value of V divided by N so that when I put this in, it's going to be equal to 0. And the easiest thing to do in this particular case is solve it by guessing and checking. And to make an educated first guess, I'm going to use the N divided by V for an ideal gas under these conditions. So my ideal gas equation is pressure times volume is the number of moles times R times T. I want V divided by N. And I want to get rid of the P, so I'll divide P by both sides, and I'm going to get V divided by N is equal to RT over P. And so I can substitute in my 500 Kelvin, and my R value, and my pressure is 100 atmospheres. So it looks like I need my old friend R in liter atmospheres, 0.82206 liters times atmospheres divided by mole Kelvin. And I'm going to get liters per mole, which is exactly what I want. So I'm going to use this as an estimate for my starting point for V over N, and then solve for 0 with a guess and check. So I'll do that on Excel. Stay tuned.